So, a little bit about myself. I do security stuff. I'm not into the whole, give my whole life spiel. But I do quite a bit on Twitter. So there's my Twitter handle. And I do blogging. So, quite a few posts, various technical, non-technical. So that's where I blog at. So just a few things first. What I'm going to talk about today is nothing new. It's already been talking about. Several people have written about it in blog posts, including myself. But I've never seen this actually talked about in an actual talk. So I thought I'd try. So along with that, as I said, it's not new. It's not thought-provoking. People are aware of this. But as I see more and more news coming out about DNS over HTTPS, I think it's important to share some of the shortcomings that may be part of the protocol. And as we get towards the end, you'll see there's some controversy about this. Some people are not happy about it and the direction it's going, but I'll cover that later. And there may be some nudity. No, I'm joking. But there's a site, dodgy site, which we'll censor. All right. So as I said, it's nothing new. People have blogged about this. So apologies if you're expecting some 0-day or something like that. Which is not. Right. So DNS over HTTPS, it's been touted as privacy first, privacy by default, and there's several articles, headlines out there with some of them. A more recent one is saying how DNS over HTTPS is going to help prevent ISPs snooping on from people. The purpose of this talk is to show that's not quite the case. Just highlighting several ways that ISPs could possibly use, or other actors such as nation states, or even attackers, criminal organizations, and that can use. So, we can't go further without first talking about DNS. Right, so DNS, acronym for the name server system. This dates back to ARPANET. So ARPANET is the origins of the internet, was a military-based system, connectivity of computers, and that was the foundation of the internet, as we know today. And the basis of the internet is TCP/IP, which is Transmission Control Protocol, and Internet Protocol Address. The IP is going to be really important because you'll see it's like going to be the foundation of a lot of the ways to work out DNS records when using DNS over HTTPS. So I'm going to start with a question. Who can give me the IP address of Google, the UK version of Google? Anyone? No? What?
How long you got?
You're not out cheating. Off the top of your head. So as you can see, we have a problem. Computers talk IP to IP, but humans don't know IP. It's going to be very difficult to remember IP address. So if you're interested, well, that was the IP address. I don't know if it is still, but that was the IP address when I did these slides. And you can see it. Really difficult. That's one site. We've got thousands of sites. It's just never going to scale. So domain name is a human readable format that it makes it easier for humans to be able to look up an IP address. So go to a system, get the details they want, and allow system-to-system communication. Sorry, I was meant to ask a question. As you can see, www.google.co.uk is a lot simpler to look up. And remember, I'm pretty sure most people in this room would have mentioned that if I asked them what is the host name for the Google UK site. So DNS is a way to resolve these host names. So it's mapping host name to IP address. And you can see this when you actually do a DNS query. So there's a dig. Dig is a utility based on Linux that you can use to do DNS lookups. So just dig in the host name, and that will return the IP address. There are different options. You can make it easier and less noisy than that, but that's the basic premise. So this is all well, but there's a problem with this. Does anyone know what the problem is? Anyone?
Yes, traffic is unencrypted.
Yes. So it's transmitted in plain text. So this means anyone that is able to sniff that traffic, be it man in the middle or side channel attacks where they can divert some of the traffic and view that traffic, they'll be able to view the DNS lookups, so the host names that were looked up. Now, from a privacy point of view, this is something, because let's say you're dodging or trying to view sites that are questionable. And I'm not going to say what, I won't judge people, but you might want to keep that private. Obviously, if it's all plain text, I can see what you're viewing. And then the other thing is, this is for more man in the middle, so you would have to get man in the middle. You can tamper with that. So I look up host A, and it should go to machine XYZ, but the attacker could change it to their rogue machine. And that's the way of diverting users to malicious servers and phishing sites and that kind of thing. Well, not phishing sites, but malicious servers posing as a real server. So, as I mentioned, plain text, there's a privacy aspect, and you'll find a lot of actors, whatever you want to term them, use this for several reasons. ISPs, perhaps marketing, governments, especially repressive regimes, spy on the citizens, vendors again. I'm not going to mention names, but I think we all kind of know some. That use this for further marketing purposes. And as I mentioned, bad actors that could use this to form a profile someone or even do man-in-the-middle attacks. So, we also have to remember DNS is an old protocol. It dates around back to ARPANET, which I forgot the exact year. I think it was 70s or 80s. So it's quite old now. And it works well in the beginning. I mean, in the beginning, we never had things like organized crime and all these things that we have to worry about today from a security point of view. So fit the bill perfectly in those days. But as we move into the more modern world and times are changing, we need to retrofit it. You'll find a lot of protocols are retrofitted, HTTP being one of them. It's kind of a bolt-on security. So now we're heading to that stage with DNS, and that's where DNS-over-HTTPS comes about. Some people will cringe at this, and do cringe at this. Again, cover that later. But the basic premise is, instead of sending the DNS in a plain text transmission, you encapsulate it in the HTTPS transmission. So then that way it's encrypted. So technically, no one should be able to view that or tamper with it. So then this should help from a privacy point of view, right? No one should be able to see what DNS requests are making. So, I missed the demo, sorry. Before I begin, let me show you two parts. So one I'm going to do if I can log in. Okay, so what I have set up here is kind of mimicking a man in the middle. So I have a Wi-Fi pineapple broadcasting out and this computer is connected to it. So all traffic is going via my Wi-Fi pineapple through my laptop and out to the internet. So this way I can see requests going back and forth. I can also tamper with them, but I'm not going to show you that. I'm just going to show you the request viewing them. So the very first thing I'm going to do is do a packet dump. And I lost connectivity. 1 second. Okay, so I'm on the pineapple. And I'm going to do a TCP dump. I'm just going to route it to DNS. Okay, so what that's going to do is capture all the packets that are going through the Wi-Fi pineapple. And I'm going to do a quick lookup on the system. And I'm going to view that in Wireshark. Sorry. Right. Okay. So now we have the packet capture. We can now view it in Wireshark. I'm going to simply query out DNS requests. And the one request that I looked at was to Google, and you can see it quite clearly here that the query was for Google, and there's a response. So as you can see, DNS-over is plaintext. So the next thing I'm going to do is I'm going to stop this capture. I'm going to do a new one. I'm call it DOH. And I'm actually going to do... That didn't start. Oh, you know what? Okay. I'm going to give up on the live demo. I have a backup. We'll just revert back to the backup. I at least wanted to show at least one that was live. Alright. So. Alright, so 1.1.1 is Cloudflare, and Cloudflare provides DNS over TLS and a DNS over HTTPS. Now, if you now view this, you can see that it is now encrypted. You're not going to be able to see what the query was. And that was to my own blog post, that actual DNS lookup. So you can see that from that aspect, it's great. It provides privacy, right? And as I briefly mentioned, there's also DNS over TLS. So the difference being is instead of using HTTPS to encapsulate it, it uses TLS. Some people view this as a better means because it's less overhead, and they just view it as a cleaner way of doing it. But at the end of the day, it kind of accomplishes the same thing. It encapsulates it in an encrypted channel. You try to view that, and you're not going to be able to view much. So, question. Does anyone think this solves the privacy aspect? See a few shakes of the head? A few nods? Okay. Well, it doesn't. Don't. Alright. So if we take a step back and let's look at the way the internet works. Remember at the beginning I said TCP/IP. Now, we go back to the network classes. I'm sure many of you have seen these type of diagrams if you've been in university or studied network courses. So this is the OSI model. For those who don't know, it's a model that represents kind of a network stack. And DNS typically operates at the application level. Some might argue presentation level or lower down. But the point is, it's kind of at least the first top three. RP, on the other hand, operates at the network level. Now, why this is important is the encryption is happening at the application level, which is higher up. And you have the RP at the lower level. Looking at another model, which is perhaps a bit cleaner, the TCP/IP model, same thing. The DNS-over-HTTPS is happening at the application level, and your actual raw data transfers happen at the TCP/IP level. Technically the network level, the interface level, but just for the purpose of this talk, we'll focus on the IP level. So the thing is, the IP will always be sent with all requests. Now this is important because with that IP, you can start working backwards. There's several things that you can use from that IP, lookups that you can do with that IP, and then you can start trying to reverse back to get the original hostname. There are a bit of caveats to this that kind of throw a nuance into it. So today with cloud computing, it kind of makes this a lot harder because you have random IPs that are changing all the time. And you have sometimes the same IP being used for multiple services. And then also multiple certificates to a host. Wildcards. SAN. But you'll see those in a bit. So, the very first example I'm going to show you is just using plain HTTP. Now, this one's going to be pretty trivial. We get there. Okay, so this RP, can anyone tell me what was the hostname that I used there? Can you read that? Scripting.com. There we go. I didn't use any DNS lookups there. I worked it out. So as ISP, I can start, as I come to the end, start formulating a table of IP to hostnames for my own DNS lookup. The other one that I want to show you, is a single hosted IP. Now, I was going to show you this. I do have an example, but I don't know if I'm allowed to show it, so I decided not to. I want to avoid being in trouble, so that one's out. But the idea behind this is simple. You take the IP that's in your packet capture, and you just do a reverse lookup. So you can do this with dig. Just do it with a -X, and it will return the host name that IP typically resolves to. So you'll find cases where our IP will always resolve to a single host name. So when you do a reverse lookup, you'll find that IP. Now that's all very well and good, but how's it going to help when you can't use IPs? Well, there's another channel that you can use for this, and that is certificates. So as we see the internet moving towards more and more encrypted web, certificates can actually help in some aspect of working out the IP. And that's because of the way certificates work. So when a client's connecting to a server, the server presents a certificate. The client's saying, hey, I want to connect to server XYZ. The server will present a certificate saying, I'm XYZ. So if you can work out the server they're connecting to, you can get the certificate, you can work out what they were requesting. Now, it's not always as simple as connect to a server, you find a host name, because there are different things that come in certificates that allow for multiple hosts to be used for a single certificate. So things like wildcards. So a wildcard means any subdomain within the wildcard. So if you had like star.google.com, you could have serverabc.google.com. That will be allowable for that certificate. And then you also have subject alternative names. So there's multiple DNS or host names for a certificate. But there are ways around that. I'll show you in a bit. All right. So single host name on a certificate. So I have an example of this. Well, it has a wildcard, but it kind of obvious straight away when you view it. Just want to make sure I get it. So you can see a certificate was sent, and you can view the certificate. Pretty obvious what that guy's doing. So if those can't read it, it's started pornhub.com. And that was using DNS-over-HTTPS. So it's kind of leveraging the system. And this is the thing about hacking in a sense. Leveraging the system against itself. This is the thing I find often most fascinating about attacking and finding means of exploiting something. You can often use things within the system to exploit itself. And I always love that. So the next example I'm going to show you is what happens if you have multiple domains or host names for certificates. So as I mentioned, the last example was kind of the example, but it's pretty obvious what the person's doing. But say you had something like this. Now, believe it or not, that was Google's certificate, I think 2 years ago. Each one of those is a wildcard in a SAN entry, so that's thousands of servers. Good luck trying to work out a single IP from that. But there's a way. So the way I view that is kind of like postcodes, right? If I give a postcode, in this case that certificate, it'll give me an idea of a region or a collection of servers that pertain to a single IP address. And if I can find something within the traffic that helps me narrow it down further, then I can pinpoint it even further. such as like a an actual address that you associate with the postcode. And this is the server name indication. So this is a field that gets sent with a request that then tells the server that you requesting hostname X or Y or whatever, and it will fetch the appropriate certificates and data associated with that server. The important thing is that's not encrypted. So in the case of that massive list of Google things, I will be able to then pinpoint that single certificate, or single hostname that they were going to. So I will now try to demonstrate that. Sorry, I'm just trying to find the certificate. Sorry, 1 second. I'm just going to narrow down the IP address to make it easier to filter. Okay, and there we go. So there's a SNI request, and as you can quite clearly see, there's the host name. That's visible because it's plain text, and that's sent with the request. Now, the interesting thing with this, and I've showed in the slide, is this now also presents a new problem with TLS 1.3. So as you saw in the previous example, you could see the certificate. That was TLS 1.2. That's all kind of viewable in plain text. TLS 1.3, I spent ages trying to find the certificate, wondering where it was in the packet capture. And I couldn't figure out why. And it turns out TLS 1.3 encrypts the certificate within the transmission. So heads up if you're looking for that in TLS 1.3. But the important thing is the SNI is still in plain text. Coming to that. Alright. So I've highlighted some examples where you can find the hostname from IP address or request. There's some other things that you can use. So mixed content. So if you load a page of HTTPS, some of the content within that page may still be called over HTTP. Going back to the very first example I gave, you could see the clear hostname. and often they'll share the same hostname for content. You can try to do calls to the HTTP itself, even though the site's over HTTPS. So one of the stipulations with HSTS is a redirect to HTTPS, is that site must always redirect from HTTP to HTTPS. So what you could do is just call the IP address HTTP IP address, and then you'll see a redirect with the actual host name in it. Other things that you can use at your disposal, Showdown, really great tool, internet search engine. There's Census, so I typically rely on multiple tools when I'm doing things. So I'd recommend using Showdown in conjunction with things like Census. ImmuniWeb is also pretty cool. They have several tools. One of the really nifty tools is the ability to map out kind of a cluster of hosts. And then this is coming back to the point I made originally, where you can kind of have lookup tables. So using all of this information to generate lookup tables, and then you can use that to kind of form your own DNS. But if you're going to do that, one thing to consider is, as mentioned in the beginning, with cloud architecture especially, you get very dynamic nature. So an IP today might point to host XYZ, but in 24 hours it might be recycled and go to somewhere else. So that could cause a problem with trying to circumvent DNS-over-HTTPS. So, what can you do to make sure that it's still private? Well, the one thing I recommend is use a VPN. Now, I know many people are vocal against using VPN, especially VPN services. I recommend using your own. Sure. I'm sure most of us in this room can set up our own VPN service, but many typical users can't. So there are still some relatively decent vendors out there. You're just going to make sure you do your homework. And the nice thing about VPN, encrypts the entire traffic, so there's nothing that anyone can get between the VPN server and the client. Someone did mention the encrypted. The encrypted server name indication. There is a protocol for that. It is supported in the later versions of Firefox, I believe. And Chrome, okay. And is that Chromium? So I imagine
it's in the DNS, I think, is where they're actually implemented it. So
okay.
Everything that uses.
Yeah. So it's not widely adopted though. That's the problem. So as we've seen, hopefully it will be. As we're moving towards TLS 1.3, a lot more sites are doing that. Encrypted SNR and HSTS. And you've got a really kind of robust method of protecting your users. Tor, being another one, well known for privacy. And then the other thing is a virtual machine. So a lot of this is looking up, hey, this request belongs to this host, but you still need to associate that request with a entity. So if you're constantly changing who's making the request, it's going to be very difficult to tie that request to a specific entity. So using virtual machines in the cloud, dynamically changing it quite a bit may help. It's not going to solve it, but it could go a bit to help it. And as I said, some of this is controversial. Mentioned DNS over HTTPS in many organizations, and you just hear people. Some of the arguments against this is they're not going to be able to intercept or view the requests, then thus work out the host names. And I get this. So organizations will use blacklisting to make sure their employees don't visit gaming sites or malicious sites. My counter argument to that is set up your own DNS over HTTPS server. If you do that, you're protecting your users. You can still manage to do your blacklisting. There's some other weird stuff out there. So one of them was Firefox for implementing DNS-over-HTTPS. Last year, they were awarded the Internet Villain. And to me, this made no sense. Firefox is using DNS-over-HTTPS, where I've shown you can kind of still work things out, but VPN providers won't blast it out. Some of the arguments were, I mean, I get it, legitimate. You can't see people viewing sites that may be related to child pornography or other nasty sites. And I get that. But there are other services out there, so yeah. And this actually just came out, I think it was this week, or last week. So Firefox is running our DNS over HTTPS by default for all US customers. So they'll have this enabled by default, touting this as privacy first and all of this. Yeah. It's still possible to get the DNS. So, yeah. I'll leave you to make up your own minds about that. All right. So, as we come to the end, don't want to keep everyone from lunch. My final thoughts on this are, I think it's a good thing. As we're moving forward, we need to start retrofitting, or coming up with new protocols on what's really decades old protocols. They were never designed to be secure. They were just designed to work. We have to start designing secure protocols. So anything that trying to move that needle in that direction is great. Some of the hype around it, maybe not so much, but it is still a step in the right direction. And it could provide a platform to build a better foundation. So build upon it, have something more secure. So as I mentioned, have DNS over TLS or DNS over HTTPS with encrypted SNI, and a HTTPS TLS v1.3, you got a pretty robust system. Attackers may be able to work out the host name if they really tried, but it's going to be difficult for them, and is it going to be worth their time? They might just go to something else. Along, as I mentioned before, the Media Hub. So it's not the magical privacy bullet. It's been made out. And like all things, there's pros and cons to this. Yeah, organizations might have a hard time, but it is starting to protect users. Like the one thing that DNS over HTTPS is going to prevent is things like DNS poisoning by a man in the middle. You can't tamper with that. So if I get a DNS response saying host X is ABC, host X is ABC, it's not going to be some attacker's machine. So there is that sort of thinking to think about as well. So, again, apologies for the issues. Word of advice, try avoid live demos. And if you do, have backups. Especially if you're doing multiple systems and across multiple screens, it's not easy. So, apologies for that. Before I do the last slide, are there any questions?
So we do have one question. So if you're running a proxy infrastructure where you're providing a master certificate so you can decode all of the potential traffic coming across, how does DNS over HTTPS impact that setup?
So typically the way those proxies work is you'd have a CA certificate that you install on that proxy. You need that public key, so the certificate, that CA certificate installed on all the clients, so that trust certificate is signed by that proxy. Those proxies typically receive the certificate, and then I'll try and mimic it as closely as possible. So they typically don't do DNS lookups. Well, they'll probably have to in order to connect out and validate the certificate. But when generating the certificate itself, they try and match the certificate like for like, other than it's signed by that CA. Yep.
What are your thoughts on? So you mentioned the privacy aspect. What are your thoughts on the whole centralization in DNS stuff? Because if the operators are effectively Cloudflare and Google, and you sort of just pass off your DNS request to them.
Yeah, that's a very good point. I actually forgot about mentioning that. I was going to mention that, so thank you. That is certainly one argument. I don't know how I feel about that. People worry about Google, Facebook, and that for privacy. And rightly so. I mean, their whole model is based on your data. Cloudflare, is their model based on your data?
I mean, they sell good data on.
Yeah. And even still, I mean, you're going to still have to go to some DNS server somewhere. So is it Cloudflare? Is it Sky, your home broadband provider? Maybe it's time we set up a community-based DNS server.
Just not with blockchain, please.
AR though. Any other questions? Nope. Alright, I was going to do one last test, but connectivity issues. So again, apologies. So thank you for coming. It's great giving the talk, and thanks for having me. And everyone rush off to lunch and go eat and ignore my rambling. Thank you.